yesterday in your class. We left off just starting to talk about combinations, right? Remember, big difference between permutations and combinations? Permutations, order matters. Okay? Order matters. It's specific of how you arrange things or whatnot. Combinations, order does not matter. And so this situation, it was picking 3 activities from the 10 camping activities. Order doesn't matter there. So we were learning how to use our combination formula, which was the combination of 10 items picked 3 at a time. And we'd set up our formula, right? What does 10 factorial mean on top? Okay. 10 times 9 times 8 times 7, all the way down to 1. And I want to demonstrate this one. I won't demonstrate them all. We'll go to using the calculator some. But I want to demonstrate this one because there's a lot of cool canceling. What does 3 factorial mean on bottom? 3 times 2 times 1 times, what does 7 factorial mean? Okay. 7 times 6 times 5 times 4 times 3 times 2 times 1. Okay, what did we learn about canceling yesterday? What can cancel here?
7.
Okay. The obvious place to get started is 7 through 1 can cancel. What else can cancel?
Get 2 on the bottom of 8 on top, the 8 will turn into a 4, and the 3 on the bottom of the 9 on top.
Okay. So we have a 2 and a 3 left on bottom. We may not have another 2 and 3, but are 2 and 3 factors of some of these pieces? Yeah. 3 can definitely cancel in the 9, can't it? On bottom, if you cancel the 3, 3 divided by 3 is going to be 1. When you cancel the 3 up top, 9 divided by 3 is going to leave us with 3. So that 9 becomes a 3. And then the 2, Autumn canceled it with the 8, which is what I would do. But you also have another option of you could cancel it with the 10 just as easily. It doesn't matter either way. So 2 cancels. 2 divided by 2 is 1. 8 divided by 2 is going to become a 4. And so the way I did it, and by the way, 1. I have a 1 left on bottom. Does that matter? No. Okay, it's going to be divided by 1. Not going to matter. So I end up with 10 times 3 times 4. And so if you want to be big brain, you don't even have to pick up the calculator to do this one, right? So 10 times 3 times 4 is 120. And I haven't decided how exactly I'm going to handle the quiz in terms of, what work has to be shown, where you can use a formula, where you can use your calculators and all that. And I'll let you guys know that once I get it figured out. But I'm still trying to demonstrate a little bit of both here. I want you guys to be able to use calculators, but I also want you to understand the work that goes behind it. Okay? Questions on this one? Okay. What about the change up on B? How many ways can a camper choose 5 activities from the 10 available activities at the summer camp? What am I going to set up here? Okay. It's a combination because, again, you're just choosing activities. Okay. Order's not going to matter. We're picking from 10, and how many are we trying to pick out? Trying to pick out 5. So, not properly read, 10C5. Okay, shorthand way. But it's the combination of picking 10 objects 5 at a time. So if we set this up, oops, I don't really need that big. We set this up, what goes on top? On top is always going to be the bigger number, left number. On bottom, we have the littler number first, so 5 factorial, r factorial, and then the 2 numbers subtracted. So 10 minus 5 factorial. Now, when we clean this up, it's 10 factorial over 5 factorial times 5 factorial. I gave you that hint yesterday that those 2 numbers on the bottom will always add to be the top number. Okay, that's not coincidence. Do the math. We know what 10 factorial means, right? That is 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. 5 factorial is 5 through 1. Another 5 factorial is another 5 through 1. And then, if you're doing this by hand, look for some cleanup options, right? What do you see? Okay. We can definitely get rid of 5 through 1. Can we get rid of some of those other numbers? Okay. And there's several different ways you can do this, yes? Okay, I mean, yeah, 5's going to have to cancel with the 10. 4 is going to have to cancel with the 8. And 3 is going to have to cancel with the 9. Well, no, actually, 9 or 6. And here's actually what I like to do. What do you know about 3 times 2? 3 times 2 is 6. So what could I do? 3 times 2 and 6 could cancel, right? There's not just one right way to do the canceling. Okay, it's all just cancel, it's all just fractions. So if I take my 3 times 2 and cancel with my 6, my 4 is going to cancel with the 8. 8 divided by 4 leaves me with 2. 5 cancels with the 10. 10 divided by 5 leaves me with 2. So I personally end up with mine 2 times 9 times 2 times 7. Yours may look slightly different, but it should multiply to be the same, which is 252. Okay. Okay, got the basics here, yes? Okay. As you look at the next set, A asks us what is 9C2, so the combination of choosing 9 things, 2 at a time. And B asks us what is 9C7. And then C asks us to compare those. So let's look and see what happens here. Okay? I'm not saying we have to work 9C2 out all the way, but let's at least set it up. What is the setup here? In order to do the combination of 9 things, pick 2 at a time. What goes on top? 9 factorial. What goes on bottom? 2 factorial times 9 minus 2 factorial, which, I clean it up one more step, it's 9 factorial over 2 factorial and 7 factorial. Now, I'm not going to write it all out and do all the canceling. You can if you want. You can also, have you played around with the calculators today? I showed you NPR yesterday. We talked about NCR, yes? It's on your calculator right there in that same area. So again, remember it's a probability button, a math menu. You're looking for a probability. For me, in order to do this, 9, I have to do the probability button, and then I'm going to arrow over and pick NCR. So there's my 9C2. Did you get what I got? 36. Okay. Have you started the setup for the next one? What do you mean? So that's part of our formula here if we're working it out by hand. If you're just using the shortcuts on the calculator, you just enter the 9C2. Is that where we're confused?
Yeah.
Okay. Yeah, and the other option on the calculator, you could enter 9 factorial divided by 2 factorial divided by 7 factorial. You can do it that way too, but if you're going to use a calculator, you might as well just, go all out with a shortcut. Okay. What about B? 9C7 means I'm doing what? 9 factorial on top. Then we have the smaller number, so 7 factorial on bottom and 9 minus 7 factorial. What do you notice when we clean this up? Yeah, it's 9 factorial divided by 7 factorial and 2 factorial, which means this one's also going to work out to be 36. Okay. So what's the relationship between the answers to A and B? Okay. Answers are the same. And why do the answers work out being the same? What happened with those denominators? Yeah, the denominators ended up being the same, didn't they? 7 factorial and 2 factorial versus 2 factorial, 7 factorial. So answers are the same. I'm going to say because the denominators are the same. Okay. Couple mixed examples here. Okay. Do the possible outcomes represent permutation or combination? So, not doing the math here. I just want to know, is this a situation where I would use a permutation? Or is this a situation where I would use a combination? First situation being, Jennifer will invite 3 of her 10 friends to a concert. What do you think here? Why?
Because it's not a set of 3 friends that you can pick in there.
Yeah. Does the order that she picks those friends matter? No, it just matters if you're one of those 3 friends picked, right? There's no difference between being picked first, second, or third. So order doesn't matter. So this indeed does represent a combination. Okay. And again, the reason is order does not matter. Okay. B then. Jennifer must decide how she and her 3 friends will sit at the concert. Permutation or combination? Why? Yeah. She already has her 3 friends picked at this point. It's how are they going to arrange themselves at the concert? Okay. If we go back to yesterday when it was Gabriella and arranging a playlist, yes? You know, that was, I used songs ABC. This would be like using ABCD for Jennifer and her 3 friends. Okay? ABCD is not the same as BCDA, which is not the same as CDAB, so on and so forth. Okay, so how you arrange how you're sitting there, not the same. So this is representation of a permutation. And it's a permutation because order matters. Anytime you are talking about arranging something, order matters. Okay? Okay, down at the bottom. We are going to use the calculator onto doing these. I didn't really give us directions here. My fail, I guess. But we're actually going to mathematically figure out these answers. So how many different ways can a 4-person team be chosen from a group of 8 people? Thoughts on how I'm going to do this? Okay, so first of all, we do need to decide, is this a combination or permutation? You're claiming combination? Does that make sense? She's saying combination, order doesn't matter. We're picking a 4-person team. Does it matter which place you're picked in? No, because we're not assigning positions. It would be different if we said specific positions or something. So, this is indeed going to be a combination. And how are we doing this combination? We're picking from how many people for how many slots. We're picking for 8 people for 4 slots. Now, you can do the setup and do all the workout if you want. Or I'm looking at the fact I still have to get to probability, and I ran out of time this morning, and I don't want to do that again. So, what's the other option you can do? Grab the calculator, yes? Again, there's a probability button. It's in your math menu, under a probability menu. It's there somewhere, right? Casio's is just right there on the screen, it appears. So, what are you finding for 8C4? 70. Okay, number 2. How many ways can 12 runners in a race finish first, second, and third? Okay. Does order matter? Yeah, because now we're talking first, second, third. So this is indeed a permutation. How many are we picking from? 12. For how many positions? 3. So you're doing 12P3. Okay. Calculator says 1,320. And C. You might actually have to think now again. Can't just say it's the other answer since I gave you 3 examples here. How many ways can 11 contestants for an award be narrowed down to 3 finalists? Combination? It says 3 finalists. Does order matter? No. Again, we're not assigning placings. So this is a combination. Picking from 11 to fill in 3 positions. What is 11C3? 165. Okay. I know, I ran through those last ones, but I want to spend some time on probability. And I will, honesty from me, the probability is going to be the hard part of the homework. Okay? I tried to get some good examples here, but I know it's going to be the tough part of the homework. So, good thing we have tomorrow to handle questions if we need to as well. Okay. So we're going to, on this back side, we're going to talk about using permutations and combinations to find probabilities. Okay, you guys know the basic idea of probability, right? On the bottom is your total possible outcomes. On top is the number of favorable outcomes. We're still using that idea, but we're going to use combinations and permutations to find those numbers. So here we have a teacher chooses 5 students at random from the names shown to work together on a group project. What is the probability that the 5 students' names all begin with a consonant? Shall we start with the vocabulary word of consonant? What is a consonant?
Any letter that's not
Yeah, think opposite vowel. What is a vowel?
A, B, I, O, U.
Okay, I'm going to say A, E, I, O, U. I don't think actually Y matters here, but I'm just going with my vowels are A, E, I, O, U, so everything else is a consonant. So, let's do some basic counting here. How many names are on this page? Because we're going to have to know that. That's what I have. Okay, there's 18 names. Obviously, we're going to have to know how many begin with a consonant, since that's what we're talking about finding the probability of. Okay. So 13 begin with a consonant. Okay, we'll worry about B here in a moment. So, okay, think probability, yes? We're talking about picking 5 student names, probability that they all begin with a consonant. So that means the denominator is how many groups of 5 can there be? So if the denominator is just in general, how many groups of 5 can I be? I'm going to ask what should we do with the denominator. Let me back up and ask a question here. Are we going to be using permutations or combinations on this problem? Does order matter when we pick these groups of 5?
No.
Okay, order does not matter when we pick these groups of 5. So throughout this particular problem, we're going to be talking combinations. I meant to ask that earlier, I forgot. Which means when we're setting up our fraction, we're going to do a combination to find the denominator, and we're going to do a combination to find the numerator. Okay? So there's, I've decided it's combinations. On bottom, all the combinations of 5-person groups. How would I find all the combinations of 5-person groups? Well, we're going to do the combination of picking from 18 names, picking 5 at a time, yes? So my denominator, I'm going to do 18C5. Combination of 18 names, picked 5 at a time. Or picking from 18 names, 5 at a time. Now, the top. What is the group of interest here? What is the favorable outcome? We're looking for groups where what? They begin with a consonant. So we're still picking groups of 5, but this time we're only picking from the 13. And so 13C5. Okay? So on top, it's groups that only have 5 people beginning with consonants. The denominator is everybody. Put these numbers in your calculator. What is 13C5? 1,287. What is 18C5? 8,568. I do have a percent answer as a final answer on this one. So in order to do the percent, you're going to divide, yes? As a decimal, I had 0.15021, yada, 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 which is approximately what percent? 15%. Okay. That's our first intro there. We're going to try B and see if we can change it up. Same scenario on B, but this time it's what's the probability that the students' names, 5 students' names, end with a vowel. So before I really start into the problem, I need a new number here. How many student names end with a vowel? I have 12 written down. Okay. So, same idea as earlier. Denominator. How many possible 5 student groups are there? Or in other words, how are we going to find that? And that is doing your 18C5, picking from all 18 students, picking 5 at a time. Numerator. How many, what are we asking this time? How many 5 student groups end with a vowel? So this time you're only picking, you're not picking from all 18 students, you're only picking from the 12 that already end with a vowel. So 12C5. Okay. What do you got? 792 is my top number. Okay. Bottom number is still 8,568. 0.0 something. 9243, so on and so forth. As a percent, yeah, I actually, for whatever reason, don't ask, have 9.24%. Actually, I know why I did that. I went to check with the book, and the book said 9.24. Because I do remember I'd only written down 9, and the book changed it up, so. Okay. So when you're asked to do probability today, we're doing permutations and combinations. So we have to think hard here. Okay. Either I've really sped things up from last period or for this morning's, or we're just doing really well on time because we're in a good position here. Okay. Company wants to form a committee of 4 people from its 12 employees. How can you use combinations to find the probability that the 4 people newest to the company will be selected? Well, they gave us a big old hint there, didn't they? Did you catch it? How can you use combinations? I guess I don't really have to ask. Does order matter? Which they've already told us order doesn't matter. It just says, what was it? 4 people, a committee of 4 people. Okay? So, we know we can start with combinations. Okay, so denominator. We're picking from the entire group. So how many are we picking for how many positions? We're picking from all 12 people to fill how many positions? 4. So denominator is going to be combination of picking from a group of 12 people 4 at a time. Numerator. The question is we're trying to find the probability that the 4 people newest to the company will be selected. So how many people are we selecting from? 4 for how many positions? 4. Okay. Now, if you think logically here, when you plug 4C4 into your calculator, this answer won't surprise you. If you're picking from 4 people to fill 4 positions, and order doesn't matter, that's just taking those 4 people and putting them in those 4 slots, so that's just one option, right? That's logic. We could have honestly just filled in a 1 on top. 12C4? 495. And I just have this one as a fraction. So 1 over 495. Okay? On Sophos, watch directions, right? They could say decimal, they could say fraction, they could say percent. Just watch for the directions, as always. Okay. Continuing on. Two more example sets, so to speak, here. Students will be chosen at random for School Spirit Awards. There are 6 athletes and 8 non-athletes who are eligible for 2 possible prizes. What is each personality? What is each probability? Don't ask. I don't know. So, permutation, combinations. Which ones should we use? In other words, is order going to matter within this problem? We're picking from those 6 athletes and 8 athletes for 2 possible prizes. Right. Doesn't differentiate between the prizes, does it? So 2 prizes. We are, again, just sticking with combinations. Probably wouldn't hurt to go ahead and get a number. How many total people are we dealing with in this problem? Right? We had 6 athletes, 8 non-athletes, so that is a total of 14 students, if you will. Just gathering some information. So A asks, what is the probability both prizes are awarded to athletes? Denominator. Denominator includes everybody. Thoughts on the denominator?
14C2.
Okay, we're picking from all 14 people for the 2 slots. Are we starting to catch on to this setup? I know it's a little different, but it's doable. So 14C2. Okay. On top, prizes are awarded to athletes. Both prizes are awarded to athletes. So you're picking from 6. It's still just for the 2 prizes, right? So 6 athletes, 2 prizes. And do you see why I quit writing all this work out? It would be really old and we'd be nowhere near this far in the notes by now, right? What's your calculator giving you for these numbers?
15 over.
Okay. 15 over 91, and that does not reduce, and they left fractions in this section. Okay. Probability both prizes are awarded to non-athletes.
8C2.
Okay. So denominator is still picking from all 14 students for 2 prizes. Prizes awarded to non-athletes. How many non-athletes do we have? And that is 8. So 8C2. I'll do the denominator for you guys. It's 91. You guys can have the numerator. 28. And it doesn't look like it, but if I recall, 28 over 91 does actually reduce. Okay. Yeah, they both divide by 7. As I said, it doesn't look like it because how many people know that 91 divides by 7? Probably not most of us. I think I kind of in my brain knew 91 divided by 13, but I think I forgot that it was 7 times 13. So, okay, what about C? Make you change up the thinking. Probability no prize is awarded to an athlete. Now, what can you go ahead and say about the denominator? We're still talking about all 14 students, yes? So 14C2. Probability no prize is awarded to an athlete. No.
8C2.
8C2 is what I was going to go with because
Both prizes would have to be awarded to non-athletes.
both prizes would be awarded to anyone but an athlete, right? And so the ones that are not athletes are the other ones. Didn't we just do this? 8C2 over 14C2? Answer's not going to change. Still 28 over 91, which is 4 over 13. One last one here. No prize is awarded to a non-athlete.
6C2.
Okay, so if no prize goes to a non-athlete, there's only 2 categories here, aren't there? So that means all prizes are going to athletes. So 6C2. And that takes me back to 15 over 91. Okay. Now, you're getting the basic gist of this. What I really wanted to get us to is these bottom sets, because there's definitely a little twist in B that I wanted to make sure that we have time for. Okay? But, last set. 4 comedians, 5 musicians performing a variety show. The order in which the performers are chosen is random. A asks, what is the probability that the first 3 performers are comedians? Okay, well, what's one change up that we haven't had yet? Order matters. The order in which the performers are chosen as random. But we're talking about order here. Who goes first, who goes second, who goes third. So that means in this particular situation, we're going to be talking about permutations. So instead of doing C over C, we're going to be doing permutation over permutation, P over P. So, denominator is everybody. What is everybody here? There's 9 people, yes? 9 people. On this example, how many are we picking? Or how many are we trying to order? We're trying to order 3. Now, the probability question, which ones are we talking about here? The first 3 performers are comedians. So what's that going to mean? We're picking from 4 comedians, so 4P3. Is this getting a little bit better? I know homework, this is going to be the rough part in homework, okay? I know it, which stresses me out, but we can deal with questions tomorrow, so. Okay, what is 4P3 over 9P3? Because I failed to write this in my notes, I'm just now realizing. 24 over what? 504? Let's see. I have a fraction answer. It at least reduces by 2. Reduces by 4, actually. What do you get?
I know. I think I did the combination. I got 1 over 21. Yeah,
1 over 21. Okay. Are you guys?
Do you still get 1 over 21? Yeah. I got that one. I had 4 over, because I did the combination.
I don't know.
And I got 4 over 84. I think.
Yeah. I got nothing on that one.
Yeah. You get 1 over 21 either way.
Yeah. Interesting. I'm going to have to think about why. Okay, so this is what? 1 over 21? Yeah. I'm going to have to think about the why in that because... Okay. I'll think about it later. Okay, B. Have you read B?
Yes.
What is the probability that the first 2 performers are a comedian, followed by a musician in the 3rd spot, basically is what that's saying. So the idea that it's comedian, comedian, musician. Okay. Think about this. I'm going to ask the same question I've been starting with all day. What goes in my denominator? How many is everybody? That is 9, and we're still trying to pick 3 positions, right? Because it's probability of comedian, comedian, musician. So 9, P3. Okay, now, think in pieces. First of all, probability that first 2 performers are comedians. So what's the probability for those 2 places going to be? Or what's the amount going to be? You're picking from 4 comedians to fill how many spots? 2. So you're going to do 4P2, and then we're going to multiply times, followed by a musician. How many options are there for the next one to be a musician? How many are you picking from? How many musicians are we picking from? 5. To fill how many spots? 1. So then I'm going to do times 5P1. Okay, so you get that combo deal, you can put them both up there. Let's see, 4P2 is 12, right? 5P1 is just 5. 9 P3 is still 504 from earlier. So my brain says 60 divided by 504. And we at least divide by 4 there. Huh, we go bigger then. Okay. Reduces to be 5 over 42. Okay. Beware of that last type of problem. Okay. Homework is in Savas, 12-3. Get going on it, okay? Work to go through what you can. Keep in mind, tomorrow I'm going to hopefully have a review worksheet ready to hand out to you guys for the quiz, which means tomorrow's going to be a workday class. Now, I'm not saying leave all this homework for you, because then you don't get the worksheet. However, what I am saying is, if we run into questions, we can go over them easily. Does that make sense? Okay.